Software Engineering Radio, episode 86, interview with Dave Thomas. Okay, welcome listeners to another episode of Software Engineering Radio. This is another episode we are recording here at UPSLA 2007, and we have a guest for this episode, so there's an interview, and our guest is Dave Thomas. Welcome to the show, Dave.
Hi, my pleasure to be with you.
Great, thanks. So why don't you introduce yourself to our audience?
Okay, so this is Dave Thomas, the old country programmer, or Eclipse Dave or Smalltalk Dave, not Ruby Dave.
Right.
I really appreciate that. Yeah, the other Dave Thomas writes such wonderful books because he does great brand maintenance. So I'm the old one.
Right. And you're, among other things, the founder of OTI. That's probably what you're maybe most known for.
Yeah, I'm probably most infamous for, yes.
So OTI stands for Object Technology International, I guess.
Yes.
So obviously you're quite a bit into object technology. So what do you think? What about the state of object technology these days?
Well, I mean, it's now, 25 years from the introduction of sort of early commercial object technology, and 40 years from Simula, which is the original technology, which shows you how long it takes for a good idea to get to the street. Mm-hmm. 20 years seems to be a common number, or at least a generation.
Yeah, right. That's maybe the point, the generation.
Yeah, the generational thing. Well, also maturing of the technology and things like that. So I think object technology is still a very, very important paradigm and a way to provide modularity and to allow people to put things together. However, I think due to the complexity of the current popular technologies and the lack of time, training, investment, that often, at least particularly with the current technologies, objects are probably, in the case of C# and Java, in many cases, at least for businesses and some engineering organizations, creating a legacy that's probably as bad or worse than the previous technologies. So, but I think it's clearly a benefit. It clearly can work. I think frameworks are a really bad idea. I mean, because basically frameworks are very hard to design. They're really a DSL. They're really a domain-specific language encoded in an object structure,
right.
and that's so language design in itself is very hard. And the problem is that because you don't encapsulate the framework in terms of components, you get all sorts of accidental coupling and complexity where someone has to basically understand a lot more about the framework than they should to be able to use it as a component. And there was so many people excited. Essentially, sort of frameworks are kind of half-finished works, right?
Yep.
In many cases, but they're intentionally so. So they're great when used by the framework experts, but when you ship them out, they become pretty difficult to use. And normal people shouldn't have to live inside a framework. They should be able to just use it more like a component or a service.
So do you think this is the problems come from the fact that you try to shoehorn something that should be a language into OO things? So do you think building DSLs, I have to ask that, building DSLs is kind of a more promising approach, or is it inherent in the problem that there is a domain you have to understand and it's inherently hard to abstract the domain and build something that expresses the domain?
I think that framework design, because it is effectively a kind of language design, is hard. I think designing a good language is hard. At least it takes a different skill set than someone that is building applications. And so I think object technology helps you, but I also think that some of the languages make it more difficult. I mean, clearly in a language like Ruby or Smalltalk, the distance between the DSL and the implementation is fairly short, versus if you're doing it in other things, then you have to generate a lot more stuff, and you have to understand the generated stuff because you can't debug it at the level of the abstraction and so on.
My impression is that object technology is good for low-level design-like stuff, but it's not an architectural paradigm because it's a different level of granularity, and on the architectural level, people talk more about components. What do you think about components were the next big thing after objects. Did they fulfill the promises?
I think we got rushed in and we shipped frameworks and we didn't ship components.
Okay.
And I think that largely had to do with the economics. I think there was a great opportunity missed, and that someone should have started the Intel of software components and built the components so they were very robust. And people have demonstrated in small ways, I mean, from TCP/IP stacks to widgets and things like that, that people will buy components. I think if people had actually invested in component engineering the way they do for silicon, that we could have a lot better quality components.
Yeah.
But there was a belief that a lot more people could do this. And so I think we kind of rushed out the technology and the frameworks. I don't think we understood how hard it was. I mean, the reality is that for a lot of people, even an easy language like Smalltalk is still hard, the abstraction processes and things like that.
Yeah.
So,
and the difference between components and frameworks from your perspective is probably black box versus white or gray box, right?
Yes. I think the reality is that everything is a gray box, but you definitely, today it's white box. So and the boundaries are not clear. So, a clear interface. So, I think the Eclipse process is something called API first, which is essentially, you define the architecture through a set of APIs, and these are concrete classes, or they can be done with a special language thing like interfaces if you have it. But they're really part of the architecture, and they're in there, and they're versioned, and they're very deep, and they're really solid boundaries that people don't cross.
Yeah. Do you think that SOA provides a right step in the right direction, and maybe like formal contracts and decoupling and I'm not talking about web services and that technology stuff, rather about the architectural style of SOA?
Does SOA have an architectural style?
Well, that's what people say. I mean, it's clearly something different from just using Whistle and SOAP. There is more to it.
Maybe. I think by the time anybody gets anything built with the current SOA tooling, that they will have been replaced by mashups using RESTful services. I just don't see all this complexity.
Over-engineered.
And you can't tell when should I be using BPAL4WS and when should I be using Java. So if someone says, well, interface and service and separating implementation from, that's the whole principle. We just talked about API first. So when someone says, well, I'm designing a service, well, the whole point, I guess if it causes you to think about the fact that you're actually providing a service and think from an interface point of view, then it's good. So that part, I guess, is good because it takes you away from this whole framework problem again, right? And it means that you think about distribution and decoupling and things like that. So I think that part is good. Yeah. The problem is the hype and the immaturity of the infrastructure, the complexity of the tools, the fact that it's another stack of vendor middleware that you can't tell what it's doing. So, I think, again, the problem is that the vendors want to turn everything into a platform game by having everything on the platform, because that means you have to buy from them versus buying from, for instance, an EAI vendor who was doing the same thing quite successfully, but they weren't getting the money. So
let's go back a little bit in time to your Smalltalk days. Maybe today are still Smalltalk days. I don't know. So what's the state of Smalltalk, and why is Smalltalk the best language ever designed? Maybe, I don't know.
Well, I certainly don't want to be the one operating the Smalltalk Museum. I think Smalltalk's a wonderful technology. It's still a very useful technology. Yeah. There are many, many things that were wrong with Smalltalk. In some cases, some of those have been actually fixed by Ruby. I think Ruby has some areas where it improves over Smalltalk. Smalltalk had the property that it let you get things done quite quickly. The programs were readable by people other than computer scientists. So
is that really true?
I've had business users and engineers who basically say, well, this is the only useful thing I've seen since Fortran.
Okay.
Yeah, and they could actually read their program because the keyworded syntax basically gave them a kind of DSL sort of thing. So the classes, so they could get a DSL fairly quickly by appropriately naming. And they found that to be pretty friendly and useful. So it was a very good technology for doing that. Had lots of problems as well. And I certainly, I think it's always important to think how you could do better than how who wants to go backwards in time.
Yeah. Is one of the reasons that Smalltalk wasn't accepted in the mainstream the fact that maybe VM technology wasn't there yet in terms of performance, scalability, or was that not an issue?
No, it's not an issue. Smalltalk VM performance was always very competitive. Arguably, it took years for the Java VM performance to even catch up. The reason that Smalltalk was eclipsed in the market was very simple.
Eclipsed wasn't intended to say eclipsed.
No.
Okay.
No. I have something else there, but I think I will pass. The basic reason was that those who were competing against Microsoft hoped that Java OS would actually give them a position in the client. So IBM and others were losing their position on the client and very concerned. So the decision for Java was really about Java OS, not about programming applications in Java. It just happened that because the JVM is more challenging to implement dynamic languages on, and largely the Sun marketing message, so Java became a weed language, which killed off all other languages as a side effect. But there was, there were lots of ways to be able to implement, and we are finally seeing now that people with JRuby and things like that are doing decent implementations, and the machines are a lot faster too. Yep. So the issues of performance are not really so critical.
Yeah. I think that's an interesting trend today that in the Java land there is this perceived separation between platform and language, and people basically agree that the language is at the end of its time, kind of, and the platform isn't.
Yeah, well, because so many people have bought it.
Sure, yeah.
And the vendors have no other platform, right?
Yeah.
So they have to make it work. But I think there's a lot of people who see, in fact, web services in some cases is an example of trying to move to something that's above the level of the Java language, right?
Mm-hmm. Yeah, move away from language to protocols in some sense.
Right.
So you already mentioned Ruby. Do you think it's a worthy successor to Smalltalk? What are the commonalities? What makes it so nice in that context?
Well, I think Ruby has the characteristic that has the uniform object notion. So everything is an object. Has a syntax that's a little more friendly than not as friendly as the Smalltalk syntax, but it doesn't look like C all the time, right? So I think it's more readable when you embed another language in it, right? Has some nice concepts in terms of Ruby in particular, has nice concepts in terms of mix-ins and things like that, and some modularities and things like that are interesting. Metaprogramming is a sort of mixed blessing because most people don't know when to use it.
Mm-hmm. You think it's overused in Ruby?
I don't think it's overused in Ruby. I think it can be dangerous when it leaks. I mean, the kind of problem is that if you Rails, for example, I haven't looked at the recent implementations, but you did a lot of some metaprogramming and redefined a bunch of fairly key stuff that was in object, which is fine if you're the implementer of Rails. The problem is if someone can read the code, they may assume that that's a pattern that they should use in their application code, which would be inappropriate. We had that problem in Smalltalk in many ways too.
It's also in C++. If you use template metaprogramming to do some performance optimization within Boost, for example, if people actually have to see it or see cryptic error messages that come from some compiler hiccup, then that's a spill out.
Yeah, I think it's the fact that we don't make it clear when you cross the line, right? So you really like to know when you're doing reflective programming. You really like to write that code in a different color or something like that, so people are clear that this is not something that you should do. Scary code begins here or something like that.
Yeah. I discussed with Eric Gamma this morning about some of the similar things, and one thing we discussed was refactoring for dynamic languages. Is it true that Smalltalk had all objects in one big bucket in the how do you say this, in the in-memory object space, and the editing tools were in the same space? So if you as an IDE wanted to know what an object can do, you just asked the object by sending it a message. So it wasn't text analysis or any of that stuff, right?
No, that's right. That was the nice thing is Smalltalk, and like most Lisp systems, had an internal representation of the program at all times, so you could actually look at it. And in fact, that's what the meta-object protocols let you do.
Yes.
You could actually look at yourself within some things we cheated on, so you really couldn't. But it looked like you could.
And Ruby doesn't have that. You don't have the IDE that has the objects live in memory. So I thought that was a big difference in how you would build the tooling for it.
Well, I think one of the lessons from Smalltalk, and certainly when we did embedded Smalltalk and cross development, and certainly built VA Java was built in Smalltalk. you realize that it's a good thing to separate your development environment in some sense from your execution environment because things can leak, right?
Right. Okay.
So I think, for instance, you could easily go along and create things on the fly in Smalltalk, which you can in JavaScript as well. If you save them, you don't remember that you actually created these objects. So there's no declarations for them. You're dependent on global stuff or things that came in that you just introduced because they're in your workspace. So, I think separation is nice, but being able to play with your program, Dan Ingalls has just demonstrated that with his new Lively stuff as well too, which Sun's announced this thing called Lively, which is open source, and basically he's implemented a lot of the Squeak stuff, object inspectors and the Morphic user interface. And
for Ruby or what?
No, for JavaScript.
Okay.
And then it runs on a JavaScript VM plus SVG.
Nice.
So I think the workspace concept was certainly a big thing. Although in Envy Developer we did refactoring and we weren't in memory and those sorts of things, but certainly that was one of the things, and it makes it in some cases easier than just working on the text. And I think that is one of the problems with IDEs and performance, and a lot of the issues is because they don't work on they have to kind of reparse and do a lot of this stuff, and so that makes the IDEs bloated and complicated because they have to redo that work all the time.
Yeah, I was about to ask you about today's development tools. After all, I mean, just to do some history here, you're the guy who facilitated, and I probably shouldn't say invented, but kind of made sure that Eclipse existed. Maybe you can tell us a little bit about that background, and then tell us about what do you think about the tool environment these days.
Well, I mean, certainly, Eclipse was built by an incredibly talented team of people, and I had the privilege to work with them. But the real issue is that IBM needed, in order to get past the Sun FUD, because we implemented Visual Age for Java in Smalltalk, we realized that we had to have an IDE that was implemented in Java for marketing reasons, if no other, that we would not ever get the blessing of Sun. We couldn't get the spinning coffee cup, and they would always do whatever, So we decided to implement what became Eclipse.
And we was at that time OTI? Was it already IBM at that time?
No, it was done. A decision was made we were in IBM at that point, but you have to understand that OTI actually ran as a separate company for 7 years. It was a wholly owned IBM subsidiary.
Oh, okay.
But that decision was made, of course, in collaboration with IBM, that this was the right thing to do. And a lot of IBM people, arguably, 70% of the people who actually involved with Eclipse were people from outside of OTI and IBMers who maybe came into the OTI kind of lab environment. And it was done in a very compressed time scale, had to be done very quickly. And, we tried to provide the development team tried to provide a Visual Age Smalltalk-like development experience because our customers were used to having an interactive environment where they could compile and test things live and so on. And so in the beginning, that wasn't so difficult, but then between Java, just after the first version of Java, nested classes and all that stuff was implemented, and that meant all the incremental compilation is very, very hard because you can't just use local scopes. You have to, and so dependency management, everything like that, inside the compilers and things like that became much more challenging. And so it evolved out of that, and it was incredibly successful thanks to a lot of people in the Smalltalk community and others who kind of embraced the idea, and I think open sourcing certainly had a big help in that, and working with universities and so on. So, today it's your legacy IDE, right?
So you think it's too big, too much of a thing, or I mean,
well, yeah, I think it is. I mean, I think it takes up too much space on your desktop. You have to put up with all these classes and all this stuff. It's very complicated. Very few people know how to use it proficiently. Part of that is just due to Java itself and the huge Java class libraries. But I mean, I think, like anything else, if you were building something new today, I only think only a fool would build something the same way they did it the last time. You would benefit from the experience.
I think a lot of your arguments is about complexity versus simplicity. And in the bar recently, we talked about, I said something like, if we now went back to Lisp, people wouldn't like to do this because the language is like too simplistic. And you then said, well, what's a limitation for some is an enlightenment, is something good for others. So do you think there needs to be a language that is smaller, that has more orthogonal concepts like Lisp or Smalltalk, that lets us do more things with less complex initial building blocks?
So the short answer is very much. I think, what we need to do is find those that the essence of good language design is trying to leave out more things and try and make things more consistent. Mm-hmm. That's a very hard problem, but I think to the extent that one only has a few ways to do things and they behave consistently, that means you can count on them, and the higher level that language, then the fewer lines of code, and in the end, K-locks kill. Right. The more code you have, the more code you have to maintain. The more complicated it is, the harder it is to refactor. I think so. Anything that allows programs to be written quickly, changed quickly, tends to lead to productivity and better quality, in my experience.
Yeah. So the real Lispers will say that there is nothing like Lisp and there will be nothing like Lisp. So do you think it is Lisp and it will be Lisp, or what do you think? Is there a language on the horizon or trends on the horizon where you see this kind of approach implemented?
Well, I mean, there are lots of niche languages inside of companies. So I think if you actually look at what people are doing, they're trying to unify. So I think anyone who's used several of these languages will tell you that there's things that when they're in another language, they really, really miss. So I mean, people who only program in one language, of course, they only play one instrument. So I can understand them. The cognitive load with switching is hard. But if you talk to people who have used several different languages, they can tell you about, this is great, but if we had this other feature from this language, this problem would be way simpler.
Yeah. Scala seems to me to go in that direction a little bit. It has functional stuff. It has pattern matching from Lisp languages. It has type inference, still statically typed. So it looks to me quite promising.
Well, I think I don't know Scala.
Okay.
I'm going to go to the tutorial at eCoop because I couldn't make it here. Yeah. But I'm looking forward to. I just spoke to Martin Odersky and hope that he can do it again at eCoop. I think it's an interesting language. I think it's very complicated.
That's true. James Noble once called it the PL1 of our times.
Well, yeah. I guess it's cleaner than that, but I think I think that the type systems are very, very complicated. Mm-hmm. And so I think the ideal language from my perspective is a language which takes the best from Smalltalk, SetL, Scheme, and APL.
Mm-hmm. Yeah. APL?
Yep.
Okay.
Well, because it turns out that there are lots of things that the APL operations are very, very convenient and very efficient for both execution, for expressing certain things. Mm-hmm. I'm not arguing that I would take the APL syntax.
No, well, sure.
But there are lots of cases where that's a very compact and efficient expression. And F-script, for example, is a Smalltalk done for the Mac for scripting the user interface classes, which actually extends Smalltalk by defining something called a message pattern, so that you can actually do APL style programming in a dialect of Smalltalk. So that's kind of the. So I think there are some very interesting ideas if you can bring those languages together, and there are people working on those sorts of things. And certainly, I think Haskell's a strong contribution. Yeah. Though again, I'm not a competent Haskell programmer. Yeah. So I'm a stateful sinner.
And dirty, as Eric Meyer would call it.
That's right, dirty. Yeah, and Eric and I are comrade as arms. And as long as we can agree, and I think there's again a meeting of the minds there. He's a big fan of duck typing and structural type of a dynamic core. With a type system to help you. And I see type systems in the broader sense, like Gilad's pluggable types, the notion that a type system is really a constraint system that you impose on things. And in some sense, invariants, all these things are constraints on your program which help your program improve in correctness and find bugs. So I think separating those issues is something so you can start, you can think easily, and then you can start screwing things down, and you're saying, okay, now I want you to check for this and check for that. I think we're getting closer to where we can start seeing things like that would help developers be productive.
Sometimes I think that the most important aspect of a parenthesis static type system is to allow tool support, to have a nice IDE. So if somehow yes, of course the compiler gives you warnings and errors, but you can do this with testing, and you should test anyway. So the IDE support, I think, is one of the really big deals in static typing.
My claim is that you need the IDE in these languages, right? I mean, the reason they have to fill in this stuff is because you can't remember all the bloody APIs and everything else, and the coercions and everything like that. So, in principle, many people that use IntelliJ or Eclipse don't actually know how to write in those languages because the IDEs are doing more and more in terms of auto-completion and filling it in and so on. So, I mean, I think part of the problem there is, in fact, that the languages have all that complexity. Static typing has its place. If you actually know what you're doing and you're doing it for the second or third time, then you know what the types are. I tend to work on applications and new products, and most of the time we don't know what we're doing. So,
in the sense of exploratory.
Yeah, a lot of it is you build it 3 times, and when you're building the third time, probably you want to commit to the types and so on. So, again, I think the difference is if you're in a fast dynamic language, you tend to do test first, which gets you kind of the same thing you get from the type system. So somehow, I mean, the experience isn't that programming in dynamic languages is less reliable than programming in static languages. That's not borne out in fact. I think you just find the bugs in different ways, right?
Right. Mm-hmm. Yeah. So let's switch gears a little bit and talk about agile development. Especially in the large. Do you think agile development scales? I mean, I know that, for example, the Eclipse folks, although they're distributed and they have these various teams, they use quite an agile process, the Eclipse way. So any opinions on that?
Yeah, well, I mean, since I lived that life for many years, one of the things I do is do large-scale lean and agile transitions. So I'm currently doing, 1,000-person company and another 400-person company. Or division, and I think the reality is that there are lean and agile approaches. I think that most of the things that are currently labeled agile really deal with the individual team and the practices for that team. I think they're wonderful, but most of the things that you need in the large actually come from product manufacturing, and a lot of those, of course, came from lean. The OTI process used to be called just-in-time software, which was taken from just-in-time manufacturing from Toyota, as all the lean stuff was. And I think if you're going to build large products, you need to follow product engineering practices. And I think the difference between making agile success in the large is adding the other product engineering practices beyond what you do inside the development team. I think all the stuff that agile teams do, the scrums, the TDD, all those practices are great, and they really do help the small teams. But they're not enough if you're in a large organization, in particular a large product organization. And in fact, they're disruptive if you don't have a process for managing them overall, because there's an illusion that somehow you can take a group of 3 or 4 wild and crazy agile teams and somehow they'll just figure it out themselves. And that in my experience, that's not the case.
Can you give us 1 or 2 or 3 examples of what such product management practices are? So I guess our listeners are probably not very familiar with these kinds of things. So any good examples?
Sure. So the kind of things that we do in our process, well, in Eclipse you've probably heard of it, there's something called the end game. Yep. And so that's something, release engineering, we've called that.
So polishing the thing at the end.
At the end, and ensuring all the pieces come together, all the dependencies are managed, that the continuous build and metrics environment is all in place. So ensuring there's full transparency, recording a common database, and putting a lot of infrastructure to put in place for serious, large-scale agile development. At the beginning, we have 2 other activities, one which we call envisioning, which basically takes the concepts of the ideas from the customer or the marketplace, whether it be focus groups, house of quality, a set of techniques that are pretty well known in the product engineering, product development world, and produces essentially prototypes for what are tangible requirements.
Yep.
And then we have a definition phase, which really is a large-scale architecture, API-first design, the planning, two-level estimation and work allocation approach that deals with how you distribute work to teams, how they interact, separation of component teams from feature teams, how those things interact, and that's something that's not typically, that's not something that's you don't need that if you're not doing this large stuff. So
and you don't find it in any of the Agile literature and communities necessarily.
No, I think that's true. I haven't seen it. I mean, I know Mary and Tom have certainly done a lot with regard to Lean, but in terms of the detailed product processes, I haven't seen that. And it's it used to be called concurrent engineering. So there's a few names. So there and new product engineering, new product design is development. There's people who do that, but no, there's not so much in the Agile community, because the Agile community is doing all the good things about how the work inside of teams.
Right. It's a bit like the objects and components, right?
Same issue.
Yeah. Okay, so let's switch gears once again, and let's look a bit at the state of research. So to give the context, I'm currently involved in a research project, deal quite a bit with universities, and sometimes I'm quite a bit frustrated about... I hit a nerve, I guess.
No, you will always be frustrated at the university.
Yeah, so can you elaborate a little bit on the relationship or the lack thereof between academia, industry research development, how you have tech transfer and that kind of stuff?
Yeah, that's certainly an area that's really important for us and one where we spend a lot of time. The biggest problem is that industrial relevance has actually hurt research, because one of the problems of if you take a graduate student and they have to spend 1/3 of their PhD effort figuring out how to make their stuff work with Eclipse or J2E or C#. Well, I mean, it's fine if they want to do that in their own time and they want to be in the community. I applaud that, but often it forces people to use the wrong tools and the wrong thinking to come up with really new ideas. But there is another problem, is that the best model is customer as laboratory. So I think if you want to be successful with universities, what you want is you want the researchers coming to you, not you going to the researchers. So bringing them into your business, having them work on your problem.
So in some sense, you're saying two things. The one is that the purity of research is polluted by too early, too many specific technology
trying to make
things.
It relevant. And what that does is produce researchers who are trying to compete with industry. And in practice, industry is already on a timeline. So if what they're producing is something that's going to be built within the next 3 or 4 years by industry, it's going to be irrelevant.
I've had this experience a couple of times. I was at the Zoopsla, I was in the DSM workshop, domain-specific modeling, and I saw 2 papers. Actually, one was last year, but it doesn't matter. 2 papers or presentations that talked about this new kind of cool thing they just researched about. And actually, it was in my book 2 years ago, and the book is not a research stuff, that's just best practice. And that's one of the things where I thought, why are they spending their time on this kind of stuff? There is more challenging stuff they could look at.
Well, it's pretty shocking in the age of Google that people can't type in the keywords, because you can, in any new area, you can find almost all the papers or the history of the chain. So I think there's a lack of scholarly work in many cases. There's pressure to publish and do new things.
Yeah.
And I think there's a lot of ignorance in many cases of the fact that what's been done. This is also partly a problem in that there's many professors or their students are disconnected from reality. People in industry don't go and talk to them about the sorts of things they do. So, but yeah, I'm always, again, I sort of attribute to age, but I'm always going, if I can type this into Google, if I can type the keywords of the title of your paper into Google and get the missing references that you don't have, why can't you find them?
Yeah, true.
But I think the other problem is that the professors always constrict the students, because typically the professor has an area and students are in that area, and often, the professor is the constraint. I mean, your father prevents you from doing things, and as much as enabling you, right? And so I actually prefer that the students have the research problem and the professors help facilitate them. So that when they're owned by the student, often when these research consortia and things like that are put together, the agenda is it's about getting the money. It's about getting the partners. They don't know why they're there.
Yeah, and everybody does what they've always done under a new name.
That's right. They just repackage what they're doing. I'm sympathetic to the need for researchers and funding students.
Sure.
But I think the best thing is to get young people and bring them involved and say, here's a problem. If you can solve this problem, this will be relevant to them, because often they don't have problems. So they have to both invent the problem and the solution, right? I mean, you see people doing language design, and they have to design the application. They actually make an application that works with their language, and it's not. They're coupled, right? So they have no independent control.
Sometimes I think it should be the industry that comes up with the challenges and outlines a kind of research agenda, and then you have the researchers making it proving stuff, building a theoretical foundation, checking how far you can go, and these kinds of things. And I thought that would be more fruitful than, as you said, than universities coming up with their own problems.
I think it's very important. I mean, we've always subscribed to the model that industry is laboratory.
Who is we?
The group of people I've always worked with, and certainly all the stuff we did at OTI and we do at Bedera. We really can't do research if we don't have a problem. We don't have a customer. So it's a sort of XP model of research, right? We have no customers. So, how could we know? Like, this area looks interesting, but it's so hard to focus because there's so many problems that, if you have someone with a concrete problem and they say, well, we don't believe this can be solved, or this would be important to us if you solve it, then that's an area where people can work to it, and you have a benchmark that you can do it. You can even share it with other universities so you can work on a common problem. I think industry-defining benchmark problems is very useful.
Yeah. Okay, so to wrap this up, a question that I've asked several other people as a kind of final question. What do you think it takes to be a good software engineer, developer, programmer kind of person? What is it that makes a good programmer?
Oh, boy, if I knew that, it'd be... clearly the ability to deal with abstraction.
Modeling, and conceptual modeling.
Conceptually modeling. Yeah. Clearly the ability to communicate. I think you have to have a passion for problem solving. And I think you have to care about the code you write, in the sense it's just not enough to get it done. You have to view it as an expression. So I wouldn't go so far as to call it literature. I mean, the literate program that you really are not happy, you want to rewrite this code.
The sense of beauty for it.
You want to refine it to the point, you want to polish it, to the point that, this is good. This is something I'm proud of. I've done it, and typically reduce the bloat, to get it into a small, compact form.
Cool. Okay, is there anything else you want to leave our listeners with? Any pearls of wisdom, as I like to say?
No. I appreciate the opportunity to talk to your listeners.
Thank you very much.
Welcome their cards and letters, and if they have some questions.
Fan mail.
Yeah. Well, I don't know about fan mail, but the darts can come. But no, I think being here with Fred Brooks and other people, you just appreciate that software is hard, and making sure that, I think, mentoring and apprenticing. I mean, the whole so craftsmanship. The whole that's very important. I mean, if you really want to be good, find somebody who's really good and try and work with them. Right. Find someone who will criticize your work. So you have to get better. Right. Work with the best. Right. So and if you're the best in your organization, you're probably hurting yourself. Right. Being 3 or 4 years or 5 years the best. You should be looking for someone else to
no challenge
work with.
Anymore.
That's right. You will actually start believing that you're the
best. Okay, so thank you very much for being on the show, Dave.
Thanks very much.
Thanks for listening to Software Engineering Radio. If you want to get more information about Software Engineering Radio, or if you want to give us feedback, please go to our website at se-radio.net. You can also contact the team at team@se-radio.net, although we prefer entries in our comments system on the website so other people can see what you think. Software Engineering Radio wants to thank Henning Pauli for the intro and outro music, as well as Libsyn for providing the bandwidth. This episode of SE Radio, as well as all other episodes, is licensed under Creative Commons license. See the Software Engineering Radio website for details.